Good morning. It's February 4th, and this is your daily brief in science. Here's everything you need to know. A global study in Nature Medicine estimates 7.1 million preventable cancer cases in 2022, about 4 in 10 new cancers, driven mainly by smoking, infections, and alcohol. Analyzing data from 185 countries and 36 cancer types, the study for the first time includes 9 infection-related cancers among preventable risk factors. Lung, stomach, and cervical cancers are the most commonly diagnosed preventable cancers linked to smoking and air pollution, H. pylori infection, and HPV respectively. The researchers urge tailoring prevention strategies to regional and national contexts to maximize impact. The findings place cancer prevention within a broader public health framework, noting that prior estimates focused on deaths or single risk factors. Key messages frame prevention as risk reduction rather than blame, calling for policy and structural interventions while upholding the dignity of people living with cancer. Even incidental activities like walking or daily vigorous movement can contribute to risk reduction, though scheduled exercise remains preferable for maximum benefit. Regional variations and data interpretation limits across areas are noted, but experts view the study as a pivotal, data-informed contribution to cancer prevention. The report also highlights dietary guidance, recommending a diverse Mediterranean-style pattern with lean proteins, fruits, vegetables, whole grains, nuts, and legumes, while limiting red meat, dairy, alcohol, sugar, and ultra-processed foods. The study appears in Nature Medicine 2026 with Digital Object Identifier 10.1038/S41591-02219-7, authored by Hannah Fink and colleagues. Datroway, a Trop-2-directed antibody-drug conjugate from Daiichi Sankyo and co-developed with AstraZeneca, is under global regulatory review for breast and lung cancer with a priority review by the FDA and a potential decision in Q2 2026. The review is conducted under Project Orbis, an international collaboration to speed oncology assessments, and a SBLA is reviewed in parallel across multiple jurisdictions as additional submissions advance. Safety data from trials remain consistent with prior studies, with ongoing post-market surveillance and regulatory evaluation. Notable adverse events include stomatitis in about 63% of patients, interstitial lung disease or pneumonitis of varying grades, and ocular events around 36%, with explicit management guidance for ILD pneumonitis, stomatitis, and ocular effects. Key safety considerations call for monitoring ILD/pneumonitis, ocular adverse events, stomatitis, embryo-fetal toxicity, and reproductive counseling, including dosing adjustments and contraception guidance. Safety signals cover ILD pneumonitis, ocular events, stomatitis, and other chemotherapy-related toxicities, with labeling detailing management for ILD and ocular effects. At ASCO and ESMO, early Datroway data show favorable progression-free and overall survival trends versus Trodelvy in selected cohorts, though hazard ratios vary by trial and mature data for some studies are pending. Datroway demonstrated more robust and durable responses in highly aggressive disease, including PD-L1 negative tumors and patients unable to receive immunotherapy. The Matterhorn trial of durvalumab-based perioperative therapy reported a 29% reduction in the risk of progression, recurrence, or death, informing EU approval momentum. Tropion-Lung12 was terminated due to operational complexity after limited recruitment in a study comparing Datroway with rilvegostomig or rilvegostomig alone versus chemotherapy in ctDNA, positive stage 1 non-small cell lung cancer. Safety findings from Tropion-Breast02 align with prior ADC experience, with manageable adverse effects and no new safety signals as studies explore combinations and other Trop2 expressing cancers. A long-term look at megaherbivores shows a decline and an eastward shift across the Indian subcontinent, driven by late Holocene climate changes, especially during the Little Ice Age, combined with increasing human activity. New evidence from Kaziranga National Park in Assam, a United Nations Educational, Scientific and Cultural Organization World Heritage Site and home to the Indian one-horned rhinoceros, comes from paleoecological records preserved in mud from the Sohola Swamp. Researchers used pollen and fungal spores to reconstruct past vegetation and megaherbivore presence, tracing how climate stability in the northeast and lower human pressure supported eastward migrations and concentrations in Kaziranga. A nearly 1-meter sediment core yielded pollen grains and fungal spores, forming a natural archive of vegetation history and megaherbivore activity. The study, published in Catena and supported by India's Science Ministry, emphasizes long-term vegetation and climate shifts as key drivers of wildlife survival, migration, and extinction. It highlights that the decline and confinement of megaherbivores to Kaziranga are linked to enduring environmental changes over time. Northeastern India's comparatively stable climate and reduced human impact appear to have allowed rhinoceros populations to persist and accumulate in Kaziranga, rather than in harsher northwestern regions. Deforestation, urbanization, industrialization, floods, droughts, earthquakes, and landslides are noted as broader threats, contributing to global biodiversity loss, while the Northeast acted as a refugium for rhinoceros survival. The study's findings offer ecological insights for conservation under future climate change scenarios and aim to inform present and future management of Kaziranga and similar ecosystems. A new study from Harvard, Michigan, and Duke argues ultra-processed foods should be regulated like cigarettes due to their design and marketing aimed at compulsive consumption. The authors say health claims such as low-fat or sugar-free can obscure serious risks and amount to health washing. Published February 3 in Millbank Quarterly, the study compares UPF production and marketing to tobacco. It notes UPFs dominate calories in developed countries and are rising in exposure in developing nations, including Africa. Public health voices warn that weak regulation could worsen health systems facing rising non-communicable diseases, calling for government-led interventions. The piece situates UPFs within ongoing debates about their health impact and policy responses, reflecting differing views among researchers and health advocates. Policy implications discussed include restricting child-targeted marketing, limiting school availability, and adopting tobacco-like governance measures such as litigation and structural interventions. Experts debate whether regulation should mirror tobacco control or focus on dietary quality, reformulation standards, and diversifying the food system to reduce harm. Critics note limitations in applying tobacco-style regulation to foods, potential economic impact, and questions about the strength and generalizability of the findings. The article argues food's essential nature makes UPF regulation urgent to curb exposure, especially among children. The debate continues on whether UPFs are pharmacologically addictive or mainly exploit learned reward pathways, influencing regulatory strategy. A new cryogenic cooling material uses magnetic frustration on a QFO2 triangular lattice to sustain high specific heat at very low temperatures, enabling efficient cooling around 4 Kelvin without rare earths. The work was published in Scientific Reports on December 22, 2025, led by Noriki Terada, Hiroaki Mamiya, Akiko Saito of NIMS, and Shinji Masuyama of Kosen, Oshima College, under JST A-STEP. The breakthrough addresses supply concerns for liquid helium and scarce rare earth elements, which are critical for MRI cooling and quantum computing applications. Current regenerator samples achieve about 55% chamber filling. With spherical granulation and optimized particle size, efficiency could reach around 65%, with potential to tailor dimensions for optimal gas flow and thermal conductivity. The Scientific Reports article presents the concept of an abundant element-based cryogenic coolant, titled Innovative Cryogenic Cooling Material Using Spin Frustration from Abundant Elements. Compared with holmium-based systems, the new material shows antiferromagnetic behavior with weak field-induced magnetization, reducing magnetic noise and mechanical stress in MRI and improving reliability for high-field superconducting magnets. A collaborative effort from NIMS, Kosen, and Oshima College produced a regenerator material made entirely from abundant elements like copper, iron, and aluminum, achieving about 4 Kelvin without rare earth metals or liquid helium. A copper-iron-aluminum oxide compound demonstrated cryogenic cooling below 4 Kelvin, with the best sample reaching around 3.13 Kelvin and 0.117 watts of cooling power. Potential applications include MRI cryogenic cooling and cooling for quantum computing, driven by independence from scarce resources and environmental advantages. using abundant elements instead of scarce rare earths, could reshape the supply chain and geopolitics of cryogenic cooling for MRI and future quantum computers. Introducing a small amount of aluminum into Cuffe oxide broadens the operational temperature range and enhances cooling capacity by altering the low-temperature magnetic structure. The material delivers practical performance comparable to traditional rare earth-based cooling materials and marks the first practical magnetic regenerator for GM coolers that does not use rare earth elements. This has been your daily brief in science. To read more about these stories, follow the links in the episode bio. You can also subscribe to these updates via email at www.brief.news. For more daily podcasts about the topics you love, visit brief.news/podcasts. Tune in tomorrow. We'll be back with everything you need to know.